Hey everybody, we are now entering week 6 into our quarantine. This week we are going to cover 2 lessons, and they all have to do with circles. One of those lessons will be finding the circumference and arc length. So our objective for that one is that you'll be able to apply formulas for circumference and arc length in order to solve circle problems. Our other lesson will be on, circle and sector area. So the first one's kind of like finding the perimeter of a circle or the length of just one segment of the perimeter of a circle. The other one is more about area, finding circle area and sector area. So that objective will be to apply a formula for area of a circle in order to solve problems and word problems involving circle area, circumference, and arc length. So those are our objectives for this week, week 6. And I want to get into our notes. Sorry. So this week I bought a document camera for at home so that my videos will be hopefully work better than what they did last week. So it'll be more like what I did at school. All right. So for week 6, circumference and arc length, and I have supplied you with these notes on It's Learning. I am going to start uploading them as PDFs instead. Some people's notes were printing kind of weird last week, so I just want to start doing that in the future so they won't do that. But these are the notes I supplied you with. It says, the blank of a circle is the distance or length measured around the outside of a circle, also known as the perimeter of a circle. So the vocabulary word we're looking for there is circumference. Okay, so the circumference of the circle is like the perimeter of the circle, the distance going all the way around the circle. So there's 2 formulas that we use for that. One being 2 pi r, where c stands for circumference, 2 pi and then r stands for radius, or if instead of giving you the radius, they give you the diameter, then you could use this formula, which is the circumference equals pi times the diameter. And remember, the reason we can interchange these formulas is because, remember, 2 and r, 2 times r, even though they're not next to each other, it still means that we're multiplying all 3 of these together. So 2 times the radius is the same thing as the diameter. So that's why either one of these formulas work. All right, so remember, radius is half the diameter. It goes from the center of the circle to the outside, and the diameter goes all the way across the circle through the center. So just remembering what all those words mean. And again, circumference is the distance all the way around the circle. Okay, so we're going to do a few problems. I'm not going to do all of them to try to keep the videos not too terribly lengthy, since I know you have a lot to do with all your other classes as well. So we'll just do a few of these. Maybe we'll just do the odds or something. And I will try to go ahead and upload the notes that has all the notes on them to It's Learning as well. That way, if you want to see some other examples, you could, but not having to watch a whole video, like another hour of video or anything. All right, so the radius of a circle is 7 centimeters. Find the circumference. So the radius equals 7 centimeters, and they want us to find the circumference. So since they gave me radius, then more than likely I would rather use circumference equals 2 times pi times r formula because they gave me the radius. So circumference equals 2 times pi times 7, and multiplying 2 times 7 gives me 14. So 14 pi is my circumference. I would prefer to leave it in that form just because it's an exact answer. But if you gave it to me in decimal form, the way you would find that would be 14 times 3.14, and you would get some decimal answer. But I prefer to just keep it exact. Okay. In this case, they gave me the diameter. The diameter of the circle is 24 inches. Find the circumference. So in this case, it would be pi times the diameter. So circumference is 24 pi. And again, that's the exact answer, so that's how I would like to leave it. On the next one, they gave us the circumference, which is 48 pi. And and they are asking for the diameter this time. So we're using the formula that involves the diameter, so pi times diameter. And plug in what you know. We know the circumference is 48 pi. And then if we're solving for the diameter, if that's what we're trying to get, then you want to get that diameter by itself. So since this is pi times that, I would divide both sides by pi. The pi's would cancel out, and I'm left with that the diameter is 48. And since this was in centimeters, I would be 48 centimeters. I'm going to go ahead and do all of these. It's not taking very long to do these. I know I said I'd only do half, but it's going pretty quick. The circumference of a circle is 22 pi. They want to know the radius. So always list what they give you and what you're trying to find, and just put a question mark with what you're trying to find so you have an idea of, well, what formula do I need to use then? I need to use the one that involves C and R for circumference and radius. So circumference equals 2 pi R, or 2 pi radius. Plug in what you know, substitute in what you know, and solve for what you don't. So our goal in this case, we're trying to find the radius, so that's what we want to get by itself. So since this is 2 times pi times r, the way we eliminate or get rid of the 2 and the pi is to divide both that side by 2 pi. And whatever you do to one side, you do to the other. So the 2's cancel out, the pi's cancel out, so we're just left with the radius. 22 divided by 2 gives me 11, and then the pi's canceled out. And this was in inches, so our radius is 11 inches. So it's just using your algebra skills. Again, just you're using a formula, plug in what you know, solve for what you don't. So get the variable that you're trying to solve for by itself. Number 5, they tell me that the distance from C to B is 5. And the distance from A to C is 12, and they want you to find the circumference. So what we can do, neither one of those are the radius or the diameter. So what we need to do is we need to solve for this side here. And what we do know is this is the diameter. You can see it goes all the way across the circle and it goes through the center of the circle. So that is the diameter. And since that line goes all the way across the circle through the center, since it is the diameter, then that means this is a 90-degree angle at C. Because if you think of it, this is a circle, this is 180 degrees because it's half the circle. So 180 degrees, angle C would be an inscribed angle, so it's half of that 180, so that's 90. So pulling from our inscribed angles lesson a while back, we know that that's a 90-degree angle, this is the diameter. So we have a triangle, a right triangle here, where we know 2 of the sides, and we can find the third side using the Pythagorean theorem, which we learned last week. So just remember the side that's across from the 90-degree angle, that's your C side. Either one of these you can label A and B, it does not matter which one. So first things first, I'm going to have to figure out what that diameter is before I can find the circumference. So I'm using A squared plus B squared equals C squared, where A is 12, B is 5, and I'm trying to find C. So 12 squared gives me 144. 5 squared gives me 25. And we're trying to solve for C. 144 plus 25 gives me 169. And then to get C, we divide, or not divide, but take the square root of both sides. And the square root of 169 is 13. So that C side is 13, and that's that diameter side, AB. So the distance from A to B is 13. And now we need to use that diameter, so that's also the diameter of the circle, to find the circumference. So circumference equals pi times diameter. So pi times 13. So C equals 13 pi. So that was definitely a two-step problem. First, having to find out what the diameter was using the Pythagorean theorem, and then plugging that into our formula for circumference. All right. One more, and then we'll talk about sector length, or arc length, sorry. The circumference of the circle is 5 pi, so we know the circumference is 5 pi. If CB is 3, so the distance from C to B is 3, find AC. So they want us to find that side. Now again, this is a right angle because it's across from the diameter of the circle. So if we can find the diameter, then we can use the Pythagorean theorem to find that missing side. So basically this same type of problem, but going backwards. So we know the circumference, so then we can find the diameter by using the formula C equals pi times diameter. So that's 5 pi equals pi times d, and we're trying to get d by itself, so divide by pi. Pi's cancel out, and we're left with the diameter is 5. So in this case, the diameter is that side AB, so it is 5. That is also the C side of that right triangle. So if I label the other sides A and B, it doesn't matter which one's which for the A and the B, then I can use Pythagorean theorem to find that missing side. So A squared plus B squared equals C squared. A is the side that we don't know, and B is 3. So that's 3 squared, C is 5, so that's 5 squared, and then just solve for A, and this is an A, So we have A squared plus 9, because 3 squared is 9, is equal to 25, because 5 squared is 25, and then to get that A squared by itself, I need to subtract 9 from both sides. So that gives me A squared plus, is equal to 16. And this is the part I noticed some people messing up on last week, was instead of subtracting 9 from both sides, they had added 9 to both sides. It was just on a specific problem. I can't remember what the number was on the problem. But so just kind of remember your algebra skills. When you're trying to get this by itself, since it's plus 9, to get rid of it on that side, you have to do the opposite and subtract 9. And whatever you do to one side, you got to do to the other. All right, finishing this problem up, take the square root of both sides, and we get A is 4. Because the square root of 16 is 4, and A was that AC side, so last but not least, since they told me to find AC, I would label it as AC equals 4. So again, another two-step problem, similar to this one, just worked in opposite directions. All right, so that's all about the circumference of a circle. Now we're going to talk about just one portion of the circumference of a circle, so the arc length. So the arc length of a circle, and there's a couple, you can either call it arc length, or another term for it would be sector length. Either way is correct. So arc length or sector length of a circle is the distance or length of an arc, which is a portion of the circumference of the circle. So if we're told just to find this arc length, that's just one part of the entire circumference. So the formula that we use for that is in degrees over 360 times 2 pi r. So in degrees is this central angle here, okay? So let's say this was a 90-degree angle. So in that case, 90 over 360, that's just 1/4 of 360. So that would break down to 1/4. 1/4 times 2 pi r. Remember, 2 pi r is the whole circumference length of a circle. So it would be like 1/4 times the whole circumference. So that's how they break that down. So again, you're using the central angle divided by 360, because there's 360 degrees in a whole circle, times whatever the circumference is of that circle. All right, so let's look at some of those. Okay, given circle O with radius 2 and central angle 45. Now they didn't draw you a diagram, but sometimes a diagram is just helpful to visualize everything. It doesn't have to be drawn accurately, just labeled correctly. So the central angle is 45, and we have a radius of 2. So that's 2, that's 2. Find the measure of the subtended arc. What they mean by find the measure of the subtended arc is they want you to find that arc length. So don't let that word throw you off. They're just asking for the arc length. So I'm going to go ahead and use AL for arc length when I use my formula. So arc length equals Remember, I'm going to put that formula up here. N over 360 times 2 pi r. Okay? So N is that central angle. This is the arc length that we're trying to find, is right here to here. Okay? N is the central angle, so 45 over 360 times 2 pi, and then our radius, which is 2. And then just solving from there. Now, 45 over 360, I honestly prefer you just to reduce that fraction. Oh, I hate that I don't have my calculator here, but reduce that fraction. But that did it easily. Those school calculators were wonderful for that. But I can see if 45 goes into 360 evenly. So 360 divided by 45 gives me 8. So if I divide both the top and the bottom, the numerator and the denominator, by 45, 45 divided by 45 gives me 1. 360 divided by 45 gives me 8. So that did divide evenly. That was a nice easy one to reduce. And then we take 2 times 2 gives me 4 pi. And then to combine all that, 1/8 times 4 pi. You can think of that 4 pi as 4 pi over 1, multiply across. 1 times 4 pi gives me 4 pi. 8 times 1 gives me 8, and then reduce your fraction. 4 over 8, 4 goes into both of those. So 4 divided by 4 gives me 1, so we have 1 pi, or just pi. And then, since we divided by 4, divide this by 4, 8 divided by 4 gives me 2. So pi over 2 is the correct answer, or 1/2 pi. Either way that you write it is correct. Or 0.5 pi, whatever you prefer. So the other way you could do it is if you struggle with reducing fractions and all that stuff like what we've done, what I will accept is decimal answers. So if I take 45 divided by 360, that gives me 0.125. And then if I take that 0.125 times 4, because it's times 4 pi, so that would give me an answer of 0.5 pi. So I would also accept 0.5 pi. So if you struggle with reducing fractions, just divide that out, get a decimal, and then take it times everything else. I would, however, prefer that you go ahead and leave pi in your answer. So instead of taking instead of taking whatever 45 divided by 360 gave us, times 4 times 3.14, I don't want you to do all that. I'd rather you just take it times the 4 and then leave pi in your answer, because that's more of an exact answer. All right, let's do a couple more. Given a circle A with diameter 10 and central angle 65, I'm such a visual person, I really like to see the diagram. So we know the diameter has a length of 10, so that's going through the center of the circle. And then the central angle that we're looking at is 65. So there's a couple ways you could go about doing this. Since they gave you the diameter, instead of using, with this formula, instead of having 2 pi r here, you could just do pi times diameter. It's the same thing. Or if it makes more sense to you, you can take the diameter and divide it by 2 and get that the radius is 5, and then plug that into that formula. So whichever way is best for you. I'll go ahead and do it this way. That way we keep using the same formula every time. So since the diameter was the diameter was 10, then the radius is that diameter divided by 2, which gave us 5. So the arc length equals n over 360, so that's that central angle, 65 over 360, times 2 pi, and then our radius, which is 5. Okay, now, since we don't have the school calculators to reduce our fractions for us, I am going to go ahead and make everything to decimal, except for pi, leaving pi in the equation. So 65 divided by 360 gives me, a long decimal, so it's like 0.180, and then it goes 5 forever and ever. It repeats the 5. So I would just leave it at 0.1805 is fine. Times 2 times 5 gives me 10, and then pi, so go ahead and multiply that times 10. Oops. And we get 1.805 repeating, but I'll just leave it as that. pi. So this is approximately an answer because we had to round that decimal. But just to make it easier on us at home, since we don't have those calculators, we just have our phone calculators, that's what we'll do. All right. And again, that's this arc length from here to here. So think of this as like the crust on a pizza. We're measuring the distance of the crust on a pizza rather than the area of the pizza. All right, find the measure of arc AB. And they gave us a diagram this time. So it looks like our radius is 12. And our central angle is 45. So n equals 45. We're just going to plug that into our formula. So arc length equals 45 over 360 times 2 times pi times 12 for the radius. All right, 45 divided by 360. Again, this time, since we're at home, I'm going to, with our regular calculators, I'm going to go ahead and make that a decimal. So that's 0.125 times 2 times 12 gives me 24 pi. So 0.125 times 24 gives me 3, and then bring down that pi. So the arc length is 3 pi. Okay, I want to, okay, we'll look at them. We'll go ahead and do all these. I'm sorry. There's just so many different examples. I just want to make sure we're hitting all of them. The circumference of a circle is 24 pi. So this time they gave us the circumference. So I want you to look at our formula up here. Remember, 2 pi r is the area, or is the formula for circumference. So now when we plug into this equation, we're replacing the 2 pi r part with the 24 pi. Okay? So they want to know the arc length of a 50-degree sector. So n is 50. So arc length equals that n, which is 50, over 360, times the circumference of the circle. So instead of going 2 pi r this time, I'm just replacing that whole part right there with 24 pi, because they've already figured out that part for us. 50 divided by 360 gives me another long decimal, so 0.138. This time the 8 is repeating forever and ever. Times the 24 pi. So I'm going to take 24 times that number I just got. And we get 3.3 repeating, and then bring down our pi. If you just put 3.3 pi, that's fine. I'll accept that as well. And number 5, the arc length of a 180-degree sector of a circle P is 60 pi. So they are giving us the arc length this time. So arc length equals 60 pi. And they want to know, and it's of a 180-degree sector. So n is 180 degrees. And they want to know the radius of the circle. So that's what we got to solve for. So using our formula, I'm going to go ahead and write the formula here. Arc length equals n over 360 times 2 pi r. We're going to substitute in what we know and solve for what we don't. So arc length is 60 pi. N was 180. And then we've got the 2 pi r. Remember, r is what we're trying to solve for, so that's what we got to get by itself. So go ahead and reduce this 180 over 360. And everybody should know that 180 is half of 360, so that's just 0.5 times 2 pi r. 0.5 times 2 just gives us 1. So I'm bringing everything else down. So we've got 1 pi, and then r. And again, if it's just a 1, we don't have to put that 1 out front. And then we're trying to get that r by itself. That's what we're trying to solve for. So I'm going to divide both sides by pi. The pi's cancel out, and I'm left with 60 as my radius. Okay? I'm going to go ahead and not do number 6 just to move along so the video doesn't get too terribly long. The assignment for this is what I'm wanting you to do for me, is to do these word problems. Okay? So you gotta draw your diagram if they didn't already give you a diagram, and then use the formulas either for circumference or for arc length to find whatever they're asking you to find. Okay? The other lesson that I want us to do today was over the area. Areas of a circle and areas of sections of a circle, or sector of a circle. So for this, the definition, for area of a circle, we will use pi r squared. So area of a circle equals pi r squared. And the definition in a picture, area of a circle, we're talking about the whole circle. This is the area. And that formula, and the formula for that is pi r squared. I'm just looking off old notes, and there was some stuff I need to fix on it. And then the area of a sector is when you have a circle, but we're just doing one portion of it. We're just finding the area of one portion. So basically like a pizza slice, the area of the whole piece of the pizza slice. And then that formula is m over 360 is equal to, times pi r squared. So it's real similar to the sector length formula. The only difference is instead of using n, they use m. It still represents that central angle. And then instead of having the circumference area right here, now it's the area of a circle's formula there. Okay, so that's the difference between the two. So here's some examples. It says find the area of a circle with radius 6. So we're doing the area of the whole circle, and its radius is 6. So the whole circle where the radius is 6. So area of a circle, formula is pi r squared. So it's going to be pi times 6 squared. 6 squared gives me 36, so it's 36 pi. Okay. Next, they want you to find the area of a circle with a diameter of 29. So if the diameter, so again we're doing the whole circle. This time they gave the diameter. If the diameter is 29, then the radius is half of that. So 29 divided by 2, which gives me 14.5. So area of that circle equals pi times 14.5 squared. So on your calculator, let me put my phone on here. I'm going to turn it sideways. So if I'm doing 14.5 squared, then I'm just going to clear that out. If I do 14.5, turn your calculator sideways, and you see this x squared button right here, that's what I want you to click to square that number. Or you could have done 14.5 times 14.5, either way. But that gets us 210.25. And in case you were wondering how to find the square root from last week's, let's say I would need to find the square root of 36. I would type in 36, and then you see that x with the square root symbol and the little 2, that takes the square root of it. Okay, so that helps you out with Pythagorean theorem type problems for finding square root. And then this week, when we're having to square the radius here for area, then it's that x squared button that you hit. So 14.5 squared got us 210.25, and then we still have the pi with it. Do not forget about having the pi in your answer, because your answer is wrong if you just have 210.25. It has to be 210.25 pi. All right, number 3, find the radius of a circle with an area of 84 pi. So this time, they gave us the area of the circle, and they want us to find the radius. So the area of the whole circle is 84 pi, and the radius is what we're trying to find. So area of a circle equals pi r squared. If we replace the area of the circle with 84 pi, then, and we solve for radius. Alright, so our goal is to get that r by itself. So first things first, we want to get rid of the pi that's multiplied to it. So we divide both sides by pi. And so that leaves me, continue this over here, 84 equals r squared. Now, just like I showed you on a calculator, instead of having to square something, we're having to take the square root to get that r by itself. So you would type in 84, and then the square root button is that one that has the x with the square root and the little 2 next to it. That takes the square root of it. So since we get a nice long decimal here, we're going to go ahead and round to the nearest tenth. So that would be, instead of 9.1, since that 6 to the right of it is 5 or larger, then we got to bump that 1 up to a 2. So it's going to be 9.2. So the radius is 9.2. It says find the radius of a circle with an area of 125 pi. It's the same type of problem as what we just did there. I'm not going to do it because you've just seen one like that, just to shorten the video a little bit. Let's go ahead and jump down to 5. It says find the diameter of the circle with an area of 50 pi. So I'm going to do this one because I asked for the diameter this time instead of the radius. So the area of the whole circle equals 50 pi. And they want to know the diameter. So what I'm going to have to do is solve for the radius the same way I did up here, but then once I get the radius, I need to take it times 2 to get the diameter, because the diameter is always twice whatever the radius is. So 50 pi is equal to pi r squared. I want to get that r squared by itself, so divide both sides by pi. We get 50 equals r squared. And then you want to get r by itself, so take the square root of both sides. Sorry, I keep getting text. So 50, oops, not 51, go away. 50, and then take the square root. We get 7.1 when you round. And then since we're trying to find the diameter is 2 times r. So 2 times 7.1. Which gives me 14.2. Okay? So again, like with any other video, if I ever go too fast, pause the video, catch up, or rewatch it. Rewatch little sections if you need, because I know I tend to go fast. But it is a video, so you can rewatch it if needing. Alright, I want to do at least 1 or 2 of these as well. These are additional circle problems, more like what you would have seen on a test if we were taking a test. It says, look at the circle at the right. Rectangle RECT with dimensions as shown is inscribed in circle O. What is the area of the circle? So, when we're finding area of a circle, remember, whatever they ask for, write that formula down so that you know what you need to look for. So area of a circle is pi r squared, right? We just talked about that. So what we need to find out is what's the radius. Well, it's a little difficult to just find the radius quickly on this. But what I can do is I notice I have a rectangle. And if I draw a diagonal for that rectangle, then I end up having a right triangle where I know 2 of the sides. And I can find the c side using Pythagorean theorem. And once I know that c side is the same as the diameter. So I can take that diameter and divide it by 2 to get the radius, and then use that to get the area. Again, this is why it's a great test question. So let's go ahead and work on using the Pythagorean theorem for this triangle, so that we can find that missing third side. So the c side is the side we're trying to find. Remember, the c side is always the one across from the 90-degree angle. So these other 2 are our A and B side. Again, it doesn't matter which one's labeled which. The only one that really matters, that has to be labeled correctly is, or with a specific letter, is the C side, the one across from the 90-degree angle. All right, let's plug in these numbers and find our C side. So we got 30 squared plus 40 squared equals C squared. So 30 squared gives me 900. 40 squared gives me 1600. Add those two together, and we get 2500. And then to get c by itself, you take the square root. And you get 50. So that c side is 50. So that means the diameter is 50. So that means the radius is 50 divided by 2, which gives me 25. So we've got the radius is 25. Now we can find the area using pi r squared. So pi times 25 squared so we get 625 pi for the area of that circle. There's quite a bit of work in there. There's about 3 steps in there. 1, finding that missing diagonal so that we'd know the diameter. 2, figuring out the radius based off of the diameter. And 3, finding the area now that we knew the radius. So it's a good question, good tough question. Let's do one more. We'll just do the second one. A circle has an area of 225 pi square units. So area of a circle is what they just gave me, 225 pi. What is the circumference of the circle? So we're using 2 different formulas here. Area of a circle, which equals pi r squared, and then circumference of a circle, which equals 2 pi r. Okay, so we're going to use this to plug into this formula to find out our r, and then plug that r in here to find our circumference. So replace the area of the circle with 225 pi. So we get that equals pi r squared. Work towards getting r by itself. So divide both sides by pi. Pi's cancel out. We're left with 225 equals r squared. We want to know what r is, not what r squared is. So we got to take the square root of both sides. And we take the square root of 225, you get 15. So our radius is 15. Now we can plug that into here to find the circumference. So 2 times pi times 15. The circumference is 30 pi. So again, these would have been really great test questions if we were doing a test. So if you want to get some extra practice, you can do those next 2 if you want. It's not required, but it's up to you. I want to then, now that we worked with area of a circle, I want to work on the area of the sector. So I know I put those notes on the other page. Technically on this page, I guess the area of the sector stuff would have gone here instead of on this page. So I'm going to scribble that from that page and rewrite it over here. So the area of a sector is when you take just a portion of the circle, like a pizza slice, and find that area. And then that formula is that m over 360 times pi r squared. And I don't know why they use m this time as opposed to n like we did on the sector length, but it's the same concept. It's the central angle divided by 360. Get that decimal, take it times pi r squared. So I'm going to put that formula up here again. So that's a formula we're going to be using on all of these. All right, so we're going to find just the area of a sector of a circle. So on this first one, the radius is 9 centimeters, and the angle, the central angle, is 120. So we're going to plug that into that formula. So we'll do m over 360 times pi r squared. And let's just substitute those in and solve for the area. So 120 over 360 times pi times 9 squared. So 120 divided by 360 gives me 1/3, or 0.3 repeating. 9 squared gives me 81. So we need to take 81 times that 0.3 repeating. We get 27. And then bring down your pi. Okay? Same kind of problem. So all of this both of these lessons is all about just picking the right formula, substitute in what you know, and solve for what you don't know. So again, same type of problem. Area of the sector equals m over 360. So in this case, it's 50 over 360 times pi r squared. So pi times 2 squared. 50 divided by 360 gives me 0.13, and then the 8 repeats forever and ever. And we're going to take that times 4 pi, because 2 squared, it gives me 4. So 0.13 and then 8 repeating times 4 gives me 0.5 repeating times pi. Again, if you answered where you rounded, then I would just put 0.6 pi and accept that as an answer as well. But that's more approximate, it's not an exact answer. Alright, in this case, they gave you the diagrams. So we determined our radius is 10, and our central angle is 60. And you just plug it in, same way we did the other two problems. So area of the sector equals 60 over 360 times pi r squared, so pi 10 squared. 60 divided by 360, in my head I can tell that it's 1/6, but if you make it into a decimal, it's 0.16, and 6 is repeating, times 10 squared gives me 100, so that's times 100 pi. So take 100 times your 0.16 repeating, and you get 16.6 repeating, and then pi. Again, if you answered 16.7 pi approximately, I would accept that as well. Okay, so that next one's just similar to the other ones that we just did. I want to do one of these diameter problems where they gave you the diameter rather than the radius. So it's just one extra step. If they tell you the diameter is 16, then to find the radius, you just take that 16 divided by 2, giving you 8. And now you've got the same information as you had on the other ones. So area of the sector equals 135 over the 360 times pi r squared, so pi 8 squared. So 135 divided by 360 gives me 0.375. Take that times 64, because 8 squared gives me 64. And I get 24 pi as my final answer on that one. Okay, so I just wanted to let you know how to solve these based on whether they give you the radius in the M angle or the diameter in the M angle. But you just plug them into your formula and solve. Let's do a couple problems on this next page, and then you'll have your assignment. The area of a circle is 225 pi. What is the area of a 60-degree sector? So this time they gave us the area of the circle equals 225 pi. And they gave us the angle is 60 degrees. Okay, so area of a circle formula equals pi r squared. So remember, on our formula from this previous page, when we find the area of a circle, or sorry, area of a sector, we just take that angle that they give us divided by 360 times basically the area of the circle. So if they already gave me the area of the circle, then we replace this pi r squared part with a 225 pi. So the area of the sector is equal to the angle, 60 over 360, times the area of the circle, so times the 225 pi. So they already did the pi r squared part for us, and we just got to plug that in right there. So 60 divided by 360, we said gave us 0.16, where the 6 is repeating. Take that times the 225 pi, so times 225, and we get 37.5 pi for our answer. On the next one, they said the area of the sector is 180. I'm sorry, the area of a 180 degree sector. So that's your M right there. The area of that sector is 32 pi. We said M was 180. And they want to know what's the radius. So using the area of a sector formula equals M over 360 times pi r squared. We're going to plug in what we know and solve for what we don't. So this is 32 pi. M is 180. And then our goal then is to solve for r. So bring down the 32 pi. 180 over 360, when I divide that out, I get 0.5. And then we have that times pi r squared. So I want to get that r squared by itself. So I'm going to divide both sides by 0.5 pi. And I take 32 divided by 0.5. I get 64. The pi's canceled out. So we're left with 64 equals r squared. And then to get r by itself, you just take the square root of both sides. When you do the square root of 64, you get 8. So the radius is 8. I'll do one more and then we're going to stop. We're pushing about going on 50 minutes here. The area of the 30 degree sector of a circle is 3 pi. So area of the sector equals 3 pi. They told me the angle of that sector, so M is 30 degrees. And again, they want to know the radius, so it's just like the last problem. So the area of the sector is 3 pi equal to 30 over 360 times pi r squared. And our goal is to get that r by itself. So 30 over 360 gives me 0.08 and 3 repeating times that pi r squared. So we're going to divide both sides by that 0.083 repeating pi. This is where the school calculators would have came in a lot more handy. I'm just reducing that fraction instead. So 3 divided by 0.0833333 as far as you can go. And you get 36. So you can see what I ended up getting was like 36.000014. So what happens was it became the 14 at the end there because I can't have it go on forever and ever. So actually it would actually just give us 36. So we get 36. The pi's have canceled out. And we're left with r squared on the other side. And then take the square root of both sides. So r equals 6. Alright. So that's the end of your lesson on that second lesson there. What I want you to do on this assignment here is you're going to, it's just 2 problems. One of them has to do with like what we talked about on, let's look at them real quick. Mrs. Wheeler and Mrs. Bailey are out for a night on the town. When they stop to get pizza at Everything Plus the Crust pizza place. Mrs. Wheeler orders a pizza with a slice magnitude of 45 degrees and a radius of 8 inches, and Miss Bailey orders one with a slice magnitude of 60 degrees and a radius of 6 inches. Unfortunately, the pizza is not that good, and both ladies can only eat one whole slice. Who ate more pizza? Sorry, it says what, but it should be who. So which one of the girls ate more pizza? So on that, you're finding area of both sectors, and then comparing them. On this one, it says Mrs. Wheeler and Mrs. Bailey are out for a night on the town when they stop to get a pizza at the Only Crust Pizza Place. Mrs. Wheeler orders pizza with slice magnitude of 45 degrees and a radius of 8 inches. Mrs. Bailey orders a slice of pizza with a magnitude of 60 degrees and a radius of 6 inches. Unfortunately, the pizza was not that good, and both ladies can only eat the crust. So since they're just eating the crust, think of a circle. The crust is just this part. That's dealing with arc length. So that's from the previous lesson. So you got to find the arc length for each one of those ladies' pizzas and compare them. Okay? And then again, it's who ate more crust. All right? So what I'm expecting from you guys back is these 2 pages, the ones that say assignment at the top of them. So this one here, which was circumference and arc length, and then this one here, which talks about the pizza place, where one of them you're doing area and one of them you're doing arc length. Okay? All right. That's it for you. Have a wonderful day, and I will have meetings on Thursdays and Fridays at 1:30, from 1:30 to 2, if you need any extra help. And that's on Teams meetings. I'll have a link provided for you in It's Learning. Have a great day.